Hi everybody. This video will demonstrate how to calculate the cross product, and we will look at 3 examples of how to use the cross product to solve story problems. So as you can see here, I have these 2 vectors, a and b. We don't always have to use u and v. And we want to find the area of a parallelogram formed by these 2 adjacent sides, and we mirror them and create a parallelogram. So one way to calculate the area is to determine the cross product and then calculate the magnitude of that cross product, and that will be our area. Remember, when we talk about cross product, it's going to use what we are familiar with as the multiplication symbol, but we use A cross B with vectors. And we're going to look at the determinant form. Now notice I'm not saying the determinant because when we deal with matrices, the determinant gives us a number. We won't get a number, we're actually going to get another vector. Remember, the cross product refers to the vector that is perpendicular to 2 vectors in space. It just so happens that the cross product, the magnitude of that cross product, is the area of this parallelogram. All right? So again, what we're going to say here is, right, -2 times -2 minus 2 times 3 I. Right, here's our I, and we're going to look here. Don't forget, this is probably the most important part. This is minus, okay? All right, J. Now we're going to be looking at these, right? So 1 times -2 minus 3 times 3. Right? And that's J. Right? Plus, right? Now we're looking at K, so we're going to be using this 2 by 2 and find the determinant of that. 1 times 2 minus 3 times -2. K. Be really careful with your negatives. Again, I like to put them in brackets. It helps me visualize what I'm doing. All right, so I can see here, this is 4 minus 6, so that's -2i, minus -2 minus 9 is -11j, right? Plus 2 plus 6 is 8k. So that's going to yield a perpendicular vector, -2i plus 11j plus 8k. So we just calculated the cross product. Now, to find the area, we're going to find the magnitude of that cross product. And remember, that's the easy part. Again, negative number put in brackets, please, all right? -2 quantity squared plus 11 squared plus 8 squared. All right, that gives us, what, 4 plus 121, which is 125, plus 64, and I believe that is 189. And if you want to give a decimal, all right, 189, we'll take the square root of that, about 13.75. All right? And that is going to be the area of that parallelogram. Right? And we're going to say units squared, because I don't know what the units are. It could be centimeters squared, meters squared, and so on. Okay? So again, let's review the cross product. We're going to use the determinant form that we use with matrices. Right? I, then the determinant of this 2 by 2, minus, 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 right? J times the determinant of this 2 by 2, plus K multiplied by the determinant of this 2 by 2 matrix. All right? Properly do this, and then find the magnitude, and you'll have the area of this lovely parallelogram. Okay? Hope that helps. And let's go to our next problem. We're going to be using a very strange word called a parallelepiped. This example, we're going to be using the cross product to calculate the volume of a parallelepiped. All right, so what is a parallelepiped? A parallelepiped is a 3D object where all the sides are parallelograms. Okay, so you can see here I have this vector, and this vector, and they are adjacent sides. So again, imagine mirroring them and creating a 3D object. Finding what we call a triple scalar product. All right, we are going to find the volume of this parallelepiped. Again, remember, this is not multiply, this is dot product. And this is cross product. So this is a nice application which marries the two concepts. I personally think this is a little easier than the volume because all we're going to do is find the determinant. We put it literally in order. T on the top, U in the middle, V in the last column. All right. So we have 1, negative 2, 3. U is 3, 2, negative 2. And our V vector is 1, negative 1, negative 1. And we're just going to calculate the determinant of that. Right? So that's 1. Right? Our 1 times the determinant of this. Negative 2 minus 2. Right? Negative 2 minus positive 2. Right? Negative 1 times negative 2 is positive 2. So negative 2 minus 2. Minus, don't forget that piece, okay? Negative 2 multiplied by the determinant of, that's 2 by 2. So negative 3 minus negative 2. Okay, be very careful with your negatives. Plus 3 times the determinant of this 2 by 2. 3 times negative 1 is negative 3 minus 1 times 2, 2. Okay, so what do we have here? All right, we've got negative 4 times 1 minus, in here, negative 3 plus 2 is negative 1. Negative 1 times negative 2 is positive 2. Plus negative 3 times negative 3 minus 2 is negative 5 times 3 is negative 15. All right, if I add all of that, negative 6, so I get negative 21. And you might be asking yourself, wait a minute, how can a volume be negative? Notice this part here. The absolute value of the cross product is the volume. So our volume is 21 units. And remember, our units cubed for volume. All right. So once again, we have the cross product being used to calculate the volume of a parallelepiped. All right. So let's review that again. This triple scalar product, right? Why is it called that? Because our end product is a scalar, 21 units cubed. All right? Literally put them in order, and it really doesn't matter how you do this. You should get 21 units cubed regardless of your order. If you want to have this be out first, right? V, the dot product of V times the cross product of T and U, you should still get 21. All right, that's negative 2 minus positive 2. Again, watch your negatives and so on. You may have to watch this again just to make sure, but I hope it helps. Okay? All right. Our next example, we'll be looking at the physics concept of torque. This example helps us figure out how to use cross product to find something called torque. All right. So let's look at the problem. All right, we've got a wrench. All right, and the wrench we know is 0.25 meters long. Our formula for torque, we're going to look at this R vector, which you'll see refers to the length of the object that we're working with. Right. Here is the axis of rotation, right? And our force vector. Okay? So we first have to determine the values of these vectors. So if I first look at this, right, my wrench, I can see that that vector is going to be, right, the x is 0, my y is 0.25, and my z, right, is also 0. Now think about, so that part we have, right, no problem. Now, the other part, we have to use a little trig. I hope you can realize, remember, that's cross product, right, not multiply. So, if I think about this, right, I can see, again, that my x component is 0. My y component is going to be the magnitude of the force times the cosine of the angle. And my z, because we're going in a downward direction, that's going to be the sine. I'm going to use the sine function. All right? And when we do that, we're going to get something like this. Right? ijk, no problem. Our r vector, no problem, and I'm probably going to have to erase this a little more so it's a little more coherent. When you calculate this, you're going to get about 10.26, and here you're going to get negative 28.19. All right, so let me sort of make this a little more readable. Right, J, K, right, 0.25 and 0. All right, no problem. And again, we're going to do the same exact thing that we did in our first example with the area of the parallelogram. Just calculate our cross product. So we're going to first start with I. All right, I'm going to say 0.25 times negative 28.19, and that's going to give us negative 7.05 minus, right, J. All right, I'm going to use this and this, right? 0 minus 0, right? So that's nice. Plus K. So I'm going to look at K and use these two to find the determinant, right? 0 minus 0. So I'm finding that my torque is parallel to the negative x-axis. I refers to this, right? So we can think about that. All right, if we want to show that, again, you don't have to do this. Again, you don't even have to draw it out. But it does help for you to sort of visualize this. If you have studied this in your physics classes, you might know about something called the right-hand rule. All right, and let's change that color to visualize our torque. Again, notice we're saying it's parallel to the negative x-axis. All right, so this is going to be 7.05 Newton meters. Notice why it's Newton meters. I'm multiplying force times a distance. All right, and that is going to give you your torque. Again, you know that I'm a strong component of visualizing this. So if you have time, draw a picture. It does give you a little insight as to how to go about cross product and where it will be and so on. Well, I hope these three examples help you in understanding how to calculate torque, how to calculate cross product, and how to use the cross product to find the answers to various story problems. Thanks for watching.